Hey guys, welcome back to my channel, and in today's video we are going to solve one more LeetCode question, that is question number 997. Find the town judge. This is an easy level question and it has been asked by so many companies in last 2 years. As we can see, Amazon, Turing, Adobe, Apple, Walmart, all these companies have asked this question. So let's see what this question is all about. So in this question we are given that in a town hall or in a town, there are n people labeled from 1 to n. And there is a rumor that one of these people is secretly the town judge. And if we have to find out that a town judge exists, then we need to satisfy these three conditions. Where the first condition states that the town judge trusts nobody. So judge trust nobody is the first condition, and second condition is that everybody trusts the judge except the judge himself. And third condition is exactly one person will satisfy the above two conditions, that is that everybody trusts the judge and judge won't trust anyone. So let's see what is given. So we are provided with an array trust, where at any index of trust we are given a list of A and B, where A represents the person who trusts the B person, where A and B are person, and it signifies that A trusts B. So if a trust relationship does not exist in trust array, then such a trust relationship does not exist. So only if there is a relationship given in this array, then only we are going to consider it, else we are not going to consider any other relation. So let's try to understand this question even better using this example. Let's understand this question. So we are given that there are n people, so n is equivalent to 3. So there are 3 people. Now let's just draw like this. This is person 1, this is person 2, and this is person 3. Now as per our trust array, if I'll see, I can see very clearly at first index there is a relationship between 1 and 3, where it signifies 1 trust 3, right? And in the second relationship it is given that 2 also trust 3. So we can clearly see that both 1 and 2 trust 3, but 3 doesn't trust anyone, right? And we have already gone through the conditions to identify whether a judge exists in a town or not, and we can see that these two conditions are already satisfied, because 1 and 2 trust 3 and 3 doesn't trust anyone. So we can say that 3 is the judge of the town, right? So this will be the answer for this question. Now it is very clearly visible from this drawing explanation that this question is somewhat about graph, right? That this problem is a graph problem. And in graph problem we can clearly see that there are 2 degrees. Firstly, there is an out degree, and secondly there is an in degree. And in terms of this question, what our condition is, if any of the node, where every person signifies a node, if any of the node is having out degree equivalent to 0 and in degree equivalent to n minus 1, in that case that node is the judge node, right? We can see in this example where the in degree of node 3 is 2, which is n minus 1, because all the people in that town except that judge himself will trust the judge. So for that reason, we are saying if in degree is equivalent to n minus 1 and out degree is equivalent to 0. What out degree is signifying in this question? It's signifying that judge does not trust anyone, right? These edges are trust relationships. And if it's coming from one node to another, that means this node trusts this node. But our judge does not trust anyone in the town. That's why the out degree will be equivalent to 0 and in degree will be equivalent to n minus 1. And if these two conditions satisfies, then we can say that the node is a judge node, or we do have a judge in a town and we can return the value of it. So let's see how we can solve this question. The first thing that we identified from this explanation is that this is a graph question. But rather than directly diving into some of the graph algorithms, we have simplified this question by focusing on the main points. Like another thing that we saw in this explanation is we need to calculate in degree and out degree of all the nodes, right? Once we have calculated in degrees and out degrees, we need to check if any of the out degree is equivalent to 0 and at the same time in degree of that node is also equivalent to n minus 1. If this satisfies, these two conditions satisfies, then what we are saying, that node is a judge node, right? So we will firstly calculate in degree, then out degree, and after calculating these two things, what we are saying, just check if the out degree is equivalent to 0 and in degree is equivalent to n minus 1, then simply return that node as a judge node. And if these conditions doesn't satisfy, this means that we don't have a judge in our town. And one more edge case which is possible, that is if there are lesser relationships than the number of people. What I'm trying to say is, I'm saying if the length of this trust array is less than n minus 1, in that case we know that there won't be any judge. Why? Because what is length of t? It is 2 right now, right? So if we need to understand this condition from this example, then what we can do is we can simply draw this thing again, 1, 2 and 3, and as per this condition, what I'm saying, if length of the trust array is less than n minus 2. So for now, let's just forget that this relation exists. So now the length of trust array is only 1 and our number of people are 3. So what I will do, I will take this trust relationship and I will draw. So I am saying 1 trust 3. That's it. So now after this, if I have to find out whether there is a judge or not, the two conditions that we check, what were they? If the out degree is 0, so as per this logic, there are two nodes, 2 and 3. Both the nodes are having out degree equivalent to 0. And what we are saying, in degree is equivalent to n minus 1. So in degree is equivalent to n minus 1. Not even a single node satisfies this condition. So this node 2 we can see is not trusting any one of the nodes, and similarly these two nodes are also not trusting 2. So none of the properties that were given in the question is satisfied. That is, all the people of the town trust judge, and judge is the only person who is not going to trust anyone. So that condition doesn't satisfy, because we can see that this node which is equivalent to 2 doesn't have any in degree or out degree towards any node. So that's the reason, if this is the case, where we can say that the length of the trust array is less than n minus 2, or in layman language, if I have to explain, then the length of the relationships are less than n minus 1, or the number of people minus 1, then there will always be a possibility that one or two people are not even trusting anyone, or other people are also that one or two people are not trusting that individual, or that node is not having any in degree or out degree, and in that case our conditions are never going to satisfy, and that's the reason we will be returning -1 as an answer in this case. So after discussing all these cases, let's just go and code this solution quickly. So as we discussed, firstly we will check that edge case, that length of the trust array is, if the length of the trust array is less than n minus 1, then right away return -1, and if not, then what we are saying, create out degree array and initialize it with 0 and n plus 1, and in degree as well, and same thing, initialize it with 0 and n plus 1. After this, for a comma b in trust in degree, okay, firstly out degree of a will be plus equivalent to 1, and in degree of b will be plus equivalent to 1. Now after this, now for I in range 1 to n plus 1, if in degree of I is equivalent to n minus 1, the same condition that we discussed, and if out degree is equivalent to 0, in that case return I, else after stepping out of this loop return -1. And let's try to submit this and check. It is okay, I did one mistake, that is out degree index I. So this was the one thing. Now it will get submitted. Yeah, this is accepted. Now there is one small modification in this whole approach that I will let you know. So let me just clean this board a bit. Okay, so as we discussed in the approach 1, that we were calculating in degree and out degree, right, in separate two arrays. So if we need to just simplify this a bit, or need to concise it a bit by reducing this two array into any one, then what we can do is we can simply maintain one array. Suppose let's name it score, and in score what we can do is, for the same index that we were using there, for every I we can increment the value if it has been trusted by anyone, and we can decrement a value if that particular node is trusting other node. So what we can do is, whenever there is an out degree, then we will be doing, so what I'm trying to say is, if like for this example 1 trust 3, so what we can do is we can do score I for 1 will be subtracted, and score I for node 3 will be incremented by 1. So in this manner, at the end of the traversal, what we will be having in score array is the actual values of all the trust relationships. So what we will be checking at the end, we will be only checking if any one of these scores is equivalent to n minus 1. That's it. Because in the previous approach itself we discussed that in degree and out degree will anyhow will be 0, right? If the condition is going to be true, then out degree will always be 0, and if it's not true, then out degree won't be 0 and in degree won't be equivalent to 1, equivalent to n minus 1. So what this a single array will do will maintain the count, and at the end, if any one of the node is having this condition satisfied, then what we can say is that node is the judge node and we can return its answer. In this manner, we don't have to use two separate lists, but honestly, this is only going to concise your code. This is not going to affect the time complexity or space complexity of the solution. That's why I didn't discuss it before, because the time complexity of this approach is going to be big O of R, where R is the length of relationship array. Because suppose there are three people, like in this example, if there are three people, then all three of them can have relationship with each other. So there can be 3 in degrees and out degrees of all of them. So that can make 9 relationships, right? So there is always a possibility that the trust array is going to be longer than the number of individuals in the town. So in that way, we are traversing this trust array. So that's the reason it is going to be the time complexity, because the first loop in our code is for trust array, so that is big O of R, and then the second array is for big O of N, and because N is lesser than R and R is a dominant value, that's why the time complexity is big O of R. And space complexity, as we are going to create a array, in this case the array will be equivalent to n plus 1, so the space complexity will be big O of n for both the approaches. Even if we are using two arrays or one array, space complexity is going to be big O of n. So this was the whole solution, and let's just make those changes that we discussed. So these two will be commented out, and after this we will have one array with value 0 and n plus 1, and what we were doing, we were saying just update the score, so score of A will be subtracted and score of B will be incremented, and at the end what I'm saying, just traverse this score array and check if I is equivalent to n minus 1. If this condition satisfies, then return I, else simply return minus 1. So let's submit this and check. Here I made a huge mistake, that I is not the value that we need to check with n minus 1, because I is not the value that we need to return in this case, because like there is a score in this score array and I is the index. We need to return the index, but we don't have to return the score. So what we can do is we can simply enumerate this score array, and now we can simply compare the score and return it. Now this should work. Okay, this is accepted. So I hope this video was helpful for you all, and this was a simple straightforward graph question, and we solved it using two approaches where the time complexity and space complexity was same. So I hope this video was helpful for you all, and if it was, then like this video, subscribe my channel. I will soon come up with more such questions. Till then, keep messing with algorithms, and thanks for watching.